In today's lesson, we're going to begin by finding the volume of cylinders. In order to find the volume of a prism, you need to multiply the area of the base by the height of the prism. That uses the equation V equals capital B times H, where B represents the area of the base. While a cylinder is not a prism, finding the volume will involve using the same formula. The base shape of a cylinder is a circle. And the way that you find the area of a circle, if you recall, the formula is area equals pi times the radius squared. Rewrite the volume formula so that it can be used for the volume of a cylinder. So just like we had up above, volume equals the area of the base times the height. And since the base is a circle, we're going to replace capital B with pi r squared. V equals pi r squared, which is the area of the circular base, multiplied by the height of the cylinder. And this is the volume formula that you can use for any cylinder. Okay, so we're going to practice using that formula in our first example. Calculate the volume of the cylinder below. Express your answer in terms of pi, as well as rounding the volume to the nearest tenth. Okay, so we'll start by using the volume formula, which we've written up above. Volume for a cylinder equals pi times the radius squared times the height of the cylinder. And now we're going to look at our picture and fill in the given information. Okay, we're going to have pi times the radius squared. The radius we can see here on the circular base is 5 centimeters, so 5 squared, multiplied by the height of the cylinder, which we see right here, is 12. Okay, following order of operations, we're going to do the exponent first. 5 squared is 25, so V equals pi times 25 times 12. And then if we multiply 25 by 12, V equals 300 pi. Multiplying 300 by pi times pi, volume equals 942 and 4777961, which we then can round, is said to the nearest tenth, to approximately 942 and 5 tenths. Okay, so they wanted the answer in terms of pi. Well, if we do that, volume equals 300 pi cubic centimeters. We see that right here. Or rounded to the nearest tenth, volume is approximately 942 and 5 tenths cubic centimeters. In example 2, we're told that a water bowl for pets is designed in the shape of a cylinder that has a diameter of 14 inches and a depth of 6 inches as shown. The company that sells the water bowl states that it holds 4 gallons of water. If there are 231 cubic inches of water per gallon, evaluate how accurate their claim is. Okay, so we're going to be filling up this cylinder with water. So again, this must be a volume question. So let's see if we can calculate the volume of this cylinder. V equals pi r squared times h. And if I look at my cylinder, I need the radius. They've provided me with a diameter of 14 inches. Half of 14 would be 7, so it's a 7-inch radius, 7 squared, times the height we can see here is 6 inches. Okay, order of operations, 7 squared is 49, so we have pi times 49 times 6. And if we do 49 times 6, that gives us 294 pi. We're then going to multiply 294 by pi, which equals 923 and 6282402. Okay, so that's what the total volume is in cubic inches. Now, the company claims that the bowl will hold 4 gallons of water, and it tells us there are 231 cubic inches of water in 1 gallon. So I'm going to take this volume for the water bowl, and I'm going to divide it by 231 to figure out how many gallons this would be equal to. So I'll take my number 923 and 6282402, and I'll divide that by the 231 cubic inches per gallon. And that equals 3 and 998 3906 5. Okay, so that's how many gallons of water would fit in this water bowl. And again, they claim that it would hold 4 gallons of water. This number is very close, but 4 gallons will slightly overflow that water bowl. Okay, so the claim is nearly true, but 4 gallons will slightly overflow the bowl. Okay, it can almost hold 4 gallons. It's very close, but a little bit of water will overflow once we put in more than the 4 gallons. Example 3 says a machine part is made from a cylinder bored out of another cylinder. The outer cylinder has a diameter of 7 centimeters and the inner cylinder has a diameter of 5 centimeters. The part has a height of 4.5 centimeters. Find its volume to the nearest cubic centimeter. Okay, so looking at the machine part here in the picture, we see that it's in the shape of a cylinder, and it looks like that there has been a cylindrical hole that was cut out of it. What we're going to have to do is find the volume of the entire cylindrical shape, which would be the larger cylinder, the outer cylinder. And then we have to find the volume of the hole, which was this inner cylinder. And at the end, we'll have to subtract those to get what the total volume is. So let's start with the outer cylinder. I'm going to start with the volume formula, V equals pi r squared h. For the volume this time, the radius, the outer cylinder, is 7 centimeters across in diameter. Half of 7 is 3.5, so that's going to be the radius, and then I square it. And I'm multiplying by the height, which I see here is 4.5 centimeters. Okay, so now I'm going to have to do 3.5 squared, which is going to give me 12 and 25 hundredths. And then I'll multiply that by 4.5. And when I do that, I get 55 and 125 thousandths pi. And I'm going to keep this in terms of pi for now, and the units are going to be cubic centimeters. I'm now going to find the volume of the inner cylinder. We're using the same formula, V equals pi r squared h. And in this case, for the inner cylinder, it had a diameter of 5 centimeters. Half of 5 is 2.5, so 2.5 squared. And the height is still the same at 4.5. If you square 2.5, all right, well, that's going to give you 6 and 25 hundredths. And then we're going to multiply 6 and 25 hundredths by 4.5. And that gives us 28 and 125 thousandths pi. Again, I'm going to leave it in terms of pi, cubic centimeters. Now to get the total volume, this time, I'm going to take the entire volume of the outer cylinder, which was 55 and 125 thousandths pi. And I'm going to subtract out the hole, which was the inner cylinder, of 28 and 125 thousandths pi. Both of these are in terms of pi. Okay, since both of these are in terms of pi, I'm going to subtract my decimals, and that's going to give me an answer which will still be in terms of pi. If you do 55 and 125 thousandths pi minus 28 and 125 thousandths pi, that equals 27 pi. Okay, now up here it's said to find the volume to the nearest cubic centimeter, so I'm actually going to multiply 27 by pi. And if we do that multiplication, we end up with 84 and 823,00165. And now rounding that to the nearest cubic centimeter, it looks like 84, but that 8 right there is enough to round us up. So the volume is going to be approximately 85 cubic centimeters. Okay, so much like we did in the lesson earlier, if we have a hole in the solid, we're going to have to subtract out the volume of the hole from the volume of the entire solid. In the next part of the lesson, we're going to focus on surface area of cylinders. Remember that surface area finds the total area of the outside surfaces or faces of a solid. A cylinder is made up of two congruent circular bases and one lateral face that wraps around the cylinder. In question number 4, they want us to find the surface area of the cylinder below. In part A, it says, start by finding the area of the bases. The bases on a cylinder, if you remember, are the circular faces. The circles are parallel to each other. And in order to find the area of a circle, you use the formula area equals pi r squared. I need to know what the radius of my circle is, and I can see right up here that it has a radius of 5 centimeters. So pi times 5 squared. And if I square 5, I get 25. So the area of each circle is going to be 25 pi square centimeters. I'm going to keep my answer in terms of pi for now. Now, that's only the area of one of the circular faces. The circles are congruent to each other, so I'm going to double that. 2 times 25 pi is going to equal 50 pi square centimeters. Okay, and so this represents the area of both of the bases. Question B says, if the lateral face was laid flat, so this other face that wraps all the way around the cylinder, okay, if the lateral face was laid flat, then what shape would it be? Draw it below and label with the dimensions that you already know. Okay, so if I were to cut down the side of this cylinder, so if you think about a soda can or a can of vegetables or something like that, if you were to cut down the side of that can and then lay it flat, what shape would you get? Well, it would be in the shape of a rectangle. So I'm going to draw a rectangle. Okay, and the height of the rectangle is going to be the height of the cylinder, which in this case I can see is 12 centimeters. Okay, the base of the rectangle from here to here, this value I don't know. But remember, this was the face that wrapped around the cylinder, okay? So this went around in a circle. And if I think about distance around a circle, I can remember that that's called the circumference. So from here to here is going to equal the circumference of a circle. How could we find the missing dimension? Calculate the circumference. Okay, once we know what the circumference is, okay, that's going to allow us to be able to figure out the area of this face. So let's see if we can find what the circumference would have to be for this measurement here. To find circumference, we use the formula C equals 2 pi r. Circumference equals 2 pi times the radius, we said back up here was 5 centimeters. Okay, and so if I do 2 times pi times 5, well, 2 times 5 is just going to be 10. So I'm going to say that it is 10 pi centimeters for the circumference. Circumference here is going to be 10 pi centimeters. So now that we've determined the dimensions of the lateral face, we're going to finish finding the area of the lateral face, and then we're going to state the total surface area for our cylinder. Okay, so recall that the lateral face was in the shape of a rectangle. And if we want to find the area of a rectangle, we're going to use the formula area equals base times height. Okay, so if I look back at my picture, okay, the base right here was equal to that 10 pi centimeters, and the height was 12 centimeters. So I'm going to substitute those values in. Area equals the base, which was 10 pi centimeters, and then the height was equal to the 12 centimeters. And if I multiply 10 by 12, I get 120 pi square centimeters. That was the area of the lateral face that wraps around the cylinder. Now we're going to state the total surface area. Okay, so for the surface area, okay, well, I started by finding the area of the two circular faces back up here. The area of the two circular faces, that was 50 pi square centimeters. Okay, and I just calculated that the area of the lateral face that wraps around the cylinder is 120 pi square centimeters. I forgot to put pi on there. 50 pi were the circles, plus 120 pi square centimeters for the lateral surface area. And that is going to give us a total surface area of 170 pi square centimeters. Okay, again, when these are in terms of pi, I can add the numbers together. 50 plus 120 is 170, so 50 pi plus 120 pi is 170 pi. That is the surface area of our cylinder. Question E says, analyze the steps you took to find the surface area of the cylinder. What formula could we use to find the surface area of any cylinder? So in this example, to find the surface area, the first thing that we did was find the area of the two circles. Okay, and then we found the area of the lateral face. Okay, and once I knew both of those areas, I just simply added them together. So let's think about the calculations involved. Surface area for a cylinder. Okay, to get the area of a circle, remember that we need to do pi r squared, but then there were two of those, so we had to double it. So our surface area formula is going to start out with 2 pi r squared. Then I'm going to add to that the area of the lateral face. Okay, so remember that for the lateral face, we had to actually calculate the circumference of the circle, and we calculated the circumference by using 2 pi r, and then we multiplied by the height. So the circumference is 2 pi r multiplied by the height. And this is the formula that you can use to find the surface area of any cylinder. I can write this in a different way as well. Notice that both parts of this equation use 2 pi r. So if I factor that out, I can also say that surface area equals 2 pi r times, well, 2 pi r squared divided by 2 pi r leaves us with just r, plus 2 pi r h divided by 2 pi r leaves us with just h. So doing 2 pi r times r plus h will also get you the area, the surface area of any cylinder. So either one of these two formulas would be acceptable to find the surface area of a cylinder. The next example asks, which has a greater surface area, a cube with edge lengths of 6 inches, or a cylinder whose diameter and height are each 6 inches? All right, so let's start by calculating the surface area of the cube. Now, remember that the cube is just a rectangular prism where all of the dimensions are the same. So to find the surface area of a rectangular prism, we do 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Now we'll substitute in, okay, each of the edge lengths on the cube are 6 inches, so the length, the width, and the height are all 6. Surface area equals 2 times 6 times 6, plus 2 times 6 times 6, plus 2 times 6 times 6. And now if we multiply, 2 times 6 is 12, all right, and 12 times 6 is 72. So that's 72, and that's 72, and that's 72. Adding the three 72s together, I get 216, and the units are going to be square inches. That's the surface area of a cube that has edge lengths of 6 inches. For the cylinder, okay, well, again, I have two different surface area formulas that I can use. It really doesn't matter which one I use. I'll say that surface area equals 2 pi r squared plus 2 pi r h. And now I'll substitute in 2 pi times the radius. Well, it says here that the diameter was 6 inches, so half of 6 would have to be 3 for the radius. All right, plus 2 pi times r, again, was 3. And the height of the cylinder, the height was 6 inches. All right, well, if I follow order of operations, I'll square 3, which is 9. 2 pi times 9 plus 2 pi times 3 times 6. All right, 2 times 9 is 18, so this is going to be 18 pi plus 2 times 3 is 6. 6 times 6 is 36, so that's going to be 36 pi. And if I add 18 pi with 36 pi, that gives me 54 pi. And now I'm just going to multiply 54 by pi, which gives me 169 and 6460033. And now if I just compare the two surface areas here, I can say that the cube has a larger surface area. In our next example, we're told that a contractor builds porch columns that are painted on all surfaces with a protective sealant. If the contractor has enough sealant to cover 150 square feet, can he seal all of the surfaces of one column? All right, and looking at the picture, we can see this is what the column looks like. It looks like a cylinder, and the cylinder is 14 feet long here, which if it was standing up, it would be 14 feet tall. And we can see here that the cylinder or the column has a diameter of 2 feet. Okay, we're going to be covering all of the surfaces with a sealant. So the sealant's going to go on all of the outside faces. So this must be a surface area problem. So surface area for a cylinder, I can say the formula is 2 pi r squared plus 2 pi r h. And now I'm just going to fill in with the values. So the first value that I need is the radius. Here I can see the diameter is 2. Half of 2 is 1, so that's what the radius is. 1 squared plus 2 pi times the radius again is 1. And the height, I can see right here, is 14 feet. Okay, so now I'm going to go ahead and follow my order of operations. 1 squared is just 1. 2 times 1 is 2, so this is just going to be 2 pi plus 2 times 1 is 2. 2 times 14, that's going to be 28 times pi. All right, and now 2 pi plus 28 pi is 30 pi. If I multiply 30 by pi, well, that gives me a surface area of 94 and 247777961, and the units are square feet. So that's what the total surface area would be for one column. The contractor has enough sealant to cover 150 square feet. So can the contractor seal all the surfaces of one column? Yes. The contractor has enough sealant to cover one full column. Okay, there will actually be some left over that he could use on the next column.